There's a specific kind of moment most people can recall, but struggle to describe. Standing at the edge of the Grand Canyon for the first time. Watching a thunderstorm roll in from a mountain ridge. Hearing a piece of music that suddenly makes the room feel larger than it is. Holding a newborn and realizing something shifted in your chest that you didn't expect. Psychologists have a word for this. It's called awe. And for most of human history, it was a regular feature of daily life. Not a rare accident. Something changed, and it's not a small thing. Over the past 2 decades, researchers studying awe as a psychological and neurological phenomenon have found that this particular emotional state does something to the brain and body that almost nothing else replicates. It alters time perception. It quiets a specific neural network that is otherwise almost never quiet. It reduces inflammatory markers in the blood. It fundamentally changes how a person relates to themselves, at least temporarily. And modern life, by almost every measurable indicator, produces it less and less. This video is about what awe actually is, mechanistically. What it does inside you when it happens, and why the architecture of contemporary daily experience seems specifically designed, without any intent, to prevent it. What awe actually is. The definition problem. The word awe gets used loosely. People say they're in awe of a sports performance or a coworker's presentation. That's not what researchers mean. When psychologists Keltner and Jonathan Haidt published the first systematic scientific framework for awe in 2003, they identified 2 core features that have to be present simultaneously for the experience to qualify. The first is perceived vastness. Something has to feel larger, physically, conceptually, or socially, than the self. A mountain range. The scale of geological time. The realization that a single human life is one of approximately 100 billion that have ever existed. The second is what Keltner and Haidt called accommodation, the sense that your existing mental frameworks are not quite sufficient to process what you're encountering. Awe requires a kind of cognitive friction. The brain reaches for a category and finds that none of them fit cleanly. This combination, something vast that resists easy categorization, is what separates awe from mere admiration or beauty or even wonder. And it turns out that combination is increasingly rare in an environment where almost everything encountered in a day has been pre-processed, pre-labeled, and delivered in a format the brain can absorb in seconds. What happens in the brain and body during awe? In 2015, Keltner's lab at UC Berkeley published research measuring the physiological effects of awe experiences. They found something that surprised even the researchers. Awe was associated with significantly lower levels of pro-inflammatory cytokines, proteins the immune system releases in response to stress and threat. Of the positive emotions studied, joy, pride, love, contentment, amusement, awe produced the strongest anti-inflammatory effect. This matters because chronic low-grade inflammation is now understood to be a contributing factor in depression, cardiovascular disease, metabolic disorders, and accelerated cellular aging. The researchers were not claiming that watching a sunset cures illness. They were identifying a biological pathway through which a specific emotional experience interacts with immune function. The neural picture is equally striking. Awe is one of the few experiences that reliably quiets what neuroscientists call the default mode network, the system that activates when the brain is not focused on an external task. The default mode network is associated with self-referential thought, rumination, planning, replaying past conversations, constructing the ongoing narrative of the self. It is also, notably, almost always active. For most people, in most waking moments, this network is running. Awe interrupts it. Research using fMRI has shown that during awe experiences, self-referential processing decreases measurably. Keltner's team describes this as the small self effect, a temporary reduction in the felt sense of one's own importance, concerns, and mental chatter. Subjects report feeling simultaneously smaller and less burdened. The self briefly recedes. This is not metaphor. It is a measurable change in which brain regions are consuming resources. Time perception. Under awe. A separate line of research from Melanie Rudd at Stanford found that awe also alters time perception in a specific and consistent direction. Subjects who had recently experienced awe, compared to subjects who had experienced joy or a neutral state, reported feeling that they had more time available. They were less impatient. They were more willing to volunteer their time for others. They made more present-focused decisions rather than future-oriented ones. The proposed mechanism involves attentional absorption. When the brain is fully engaged with something it cannot immediately categorize, something vast and unfamiliar, the internal monitoring systems that track time passing are temporarily deprioritized. The experience expands subjectively because the brain is not simultaneously measuring it. For context, the average American adult checks their phone 96 times per day, or roughly once every 10 minutes of waking life. That is a device specifically engineered to produce the opposite of attentional absorption. Rapid context switching, novelty in microdoses. Nothing vast. Nothing that resists easy processing. Why modern life systematically reduces awe. This is where the research becomes uncomfortable. Awe requires specific conditions that the structure of contemporary daily life makes progressively harder to access. It requires perceived vastness, but most of what modern humans encounter in a day is human-scaled. Offices, apartments, screens. The designed world is built for human convenience, which means it is built to fit human cognitive categories without friction. It requires accommodation, the sense that existing frameworks are insufficient. But information environments are optimized for exactly the opposite. Everything pre-explained, pre-contextualized, reactions preloaded. The scroll is specifically designed to be frictionless. It requires time. Awe experiences in research conditions take several seconds to develop. The brain needs time to register the discrepancy between what it expected and what it's encountering. Rapid context switching doesn't allow that window to open, and it requires, to some degree, physical presence. Research comparing awe experienced in person versus through screens consistently finds that the physiological response, the cytokine changes, the default mode quieting, is significantly attenuated when the experience is mediated by a device. A photograph of the Grand Canyon and standing at its edge are not neurologically equivalent events. Keltner has argued that one of the unexamined costs of urbanization and screen saturation is what he calls awe poverty, a chronic underexposure to the kinds of stimuli that produce this particular emotional and biological state. His research with populations across cultures found that awe experiences, when they do occur, are most commonly triggered by nature, followed by music, then by other people doing something morally extraordinary. All three of these categories have declined as a share of daily experience for the average person over the past several decades. The awe the modern brain gets. Instead, here is the irony the research exposes. The brain is not indifferent to the absence of awe. It continues searching for experiences that produce the sense of vastness, of something larger than the self. What it tends to find in the current environment are substitutes. Viral outrage. The scale of collective anger online can produce a distorted version of the vast and hard-to-categorize sensation. True crime. The scale of human darkness. Doom scrolling through catastrophic news. Not because humans enjoy suffering, but because the brain is, in part, looking for something that registers as genuinely large. These are not equivalent to awe. They activate stress systems rather than quieting them. They produce the sensation of vastness without the self-reduction, without the anti-inflammatory cascade, without the time expansion. They are, in terms of the neurological pathway, awe-shaped holes that get filled with cortisol. There's a specific irony in this. The brain is not malfunctioning when it seeks out catastrophic news or collective outrage. It is doing exactly what it evolved to do, scanning for signals of something larger than the individual self, something that demands full attention and recalibration. In an environment depleted of genuine vastness, it works with what it has. The architecture of the attention economy happens to be very good at supplying stimuli that feel large without delivering the biological state that genuine awe produces. The sensation of scale without the reset. The feeling of something important without the quieting of the noise. Keltner's lab has spent years asking a practical question: how little awe is enough to produce measurable effects? The answer from the research is more accessible than most people expect. Studies using what researchers call awe walks, ordinary walks during which participants were instructed simply to approach their surroundings with curiosity about what might be vast or unfamiliar, found measurable improvements in well-being, reduced anxiety, and increased pro-social feelings after 8 weeks. The walks were 15 minutes long. They happened in ordinary urban environments, parks, streets, waterfronts. Participants were not taken to national parks or concert halls. The variable was not location. It was attentional orientation, specifically whether the brain was directed to look for something that might exceed its ready-made categories. What the research seems to suggest is not that modern life has made awe impossible. It's that the default settings of modern life don't produce it automatically anymore, the way they might have for most of human evolutionary history, when the uncontrolled natural world was simply present and unavoidable. The brain's capacity for awe appears to be intact. What has changed is the frequency with which the environment triggers it. There's something worth sitting with in what this research reveals. Awe is not a luxury emotional state, a reward for people who happen to visit beautiful places. It appears to be a regularly needed input for a system that evolved in a world where vastness was simply around, unavoidable, built into the texture of daily experience. The default mode network quieting, the inflammatory markers dropping, the sense of the self temporarily loosening its grip. These are not poetic descriptions of a nice feeling. They are what the research shows happens when the brain encounters something genuinely larger than itself. What the modern brain encounters at scale is a world almost entirely built to human measure, familiar, pre-labeled, optimized for frictionless processing. The question the research leaves open is not how to manufacture awe on demand. It's whether the brain notices the difference between a world that contains genuine vastness and one that has learned to simulate it. The evidence suggests it does.